In this tutorial, we're going to talk about the chain rule. And the chain rule is used to help derive functions that are functions within a function, like composition of functions. So in this, it says d dx of f of g of x equals f prime of g of x times g prime of x. And I color-coded this so that you could tell the difference as to where everything is going. Keep in mind that this very first part, this is f of g of x. I could very easily be saying here f of, oh, that's a bad f, f of u, okay, or f of x or some other variable. So g of x is what I'm plugging into my f of x function, okay? That's all that means. And I'm going to show you a couple examples of this in the next couple tutorials, so don't panic if this is confusing. Now this is using Leibniz notation. Let me write it out using Newton notation and maybe you will see the difference. Okay, so here's Newton notation. So all we're going to do, all the chain rule says is take the derivative of whatever your f of x function is, which is also known as the outside function or the outer function. Outer or outside. And the u part is considered the inside part. Okay? So what I'm going to do is I'm going to first derive whatever my first function is, just like I normally would. And then what I'm going to do is multiply the entire part by whatever the derivative of u is, whatever I'm taking my function of. So let's take a look back at the Leibniz notation. So here is the part that tells you that it's the outside function. This is the outside part. And then the g of x part would be the inside part. So this is your basic chain rule, and I'm going to show you a very, very simple example in just a few seconds using this. So here we go. Okay, so I went ahead and up here I kept the Leibniz notation and then I wrote the Newton notation underneath it. So you can see both ways as we go through this. So let's take a look at this example. It says y equals x squared plus 1 cubed. Now, one way of doing this we could go ahead and cube out x squared plus 1. However, it's time consuming and there's a more sophisticated way of doing it. So, if I were to, let's say, use the power rule here, because that's what we know so far, it doesn't seem like we could do it because it's not just one term being raised to that third power. It's its entire expression. Or what we could say is it's another function. So I'm going to rewrite this using color coding just like how I did up here with my Leibniz notation. And I'm a fan of the Leibniz notation, so I'm going to do that first, and then I will show you Newton. Okay, so what I can see here is that my outside function is acting as some term, the x squared plus 1, being cubed. So the way that I want you to think about this is, let's think of this entire inside part, this x squared plus 1, as a different variable. So maybe I'm going to use the letter t. It could be anything here. I'm just showing you what you can do here. So what we're going to do is I'm going to rewrite this, but instead of saying x squared plus 1, I'm going to write a t. Okay. So when I do that, when I look up here at my rule, it says that the very first thing I'm going to do is take the derivative of my outside function, my f function. So when I replace my inside function with one variable, it becomes very easy to see how I'm going to derive that. This is just a very basic power rule. And the derivative of anything cubed, an x cubed or z cubed or y cubed, is 3x or t or whatever squared. So I'm going to go ahead and write that out. Okay. So what you can see here is I have done only my power rule. My inside function is still being left alone. Now I want you to take a look at back here at the Leibniz notation. This very first part right here is what we just did. I took the derivative of my outside function and I left g of x alone. I haven't done anything to it yet. Now, the next part of this says, okay, well, that's nice. Now we're going to multiply by whatever the derivative of that inside function is. So down here, I'm going to write my multiplication sign, and I'm going to go up here and take a look at what g of x is. And right now, g of x represents x squared plus 1. So here's my g of x. Okay. So what is the derivative of x squared plus 1? And the answer is 2x. Okay, so what we're going to do here is we're going to clean this up a little bit. I'm going to write my y equals, and I'm going to keep my 3, and I'm going to replace t with what I substituted it for, which was x squared plus 1. And I'm going to square that, and I'm going to write multiplied by 2x. Now, we can take this one more step farther as far as simplifying goes, because this 3 and this 2x can be multiplied together, which would give me 6x, and then times x squared plus 1 squared. And this is my answer. So I kind of tried to build in the Newton notation by substituting my g of x for this u up here in the Newton. You can do this however way that you like. If you like substituting and then going back and to finish it because it might be easier, then that's fine. Do whatever you want to do. If you find it easier to leave the function there, then you can do that as well. And that concludes this tutorial.